All right, this is the first test you've had, so you probably don't know what to expect. But I think I told you I was going to show you basically the test today. I'm not going to hold it up on camera because then you can zoom in and see what the answers are. It won't be good. But I am going to show you the test. All right. And notice it looks a lot like these questions on here on the front side. On the back side, it's got a graph, and this one has that graph on it. All right. But the other one, there's more than one test, so I don't really care that you see that. I don't really care that you see, most of the time when you show a test, I really don't care that you see all the stuff on it, because pretty much you still have to study it. And it's not the same. They're not the same questions on every test. There's going to be different tests out there. All right? I'm going to review by going over. All right. Let me just do my board here first. I'll review by going over all of the problems we just did here, all the questions. And you did it last night. And we'll find some mistakes. I started to grade them. I saw some mistakes already. All right? But let's just read off each section here, okay, so I can tell you. First section, no surprise. You don't have to write this down because it's you just did this. And if you want to look at it tonight, you can see it again. First section is going to be physical versus chemical changes on the test. It's going to be the same thing. Same exact kind of questions. They won't be the exact same ones that are listed here, but they'll be very similar. Underneath that, there's going to be the heterogeneous, homogeneous mixtures, elements, compounds, and mixtures. So it's not in the same order, but that's on the next page. Underneath that, now this is something that's not up here. There's a matching section where you're going to have a lot of the new terms that we had in this chapter. There's quite a few new terms in this chapter. Normally a test in chemistry doesn't have this much memorization, but this is the first chapter, and we had no math. So there is some stuff you're going to have to just study to know. All right? And there are a lot of new words we had. Give me a new word we had in this chapter that might be in a matching section. Any new word? Okay, homogeneous. Although I'm going to have a whole section on hetero versus homogeneous, like I just said a minute ago. So, I mean, I could put that there, but you know you're going to see other questions on whether something's homo or heterogeneous. What are some other words? Endo and exothermic. Same thing. You're going to find, as I go down this next one here, endo and exothermic. I have a separate section on that. I could ask it as a matching section as well. All right, just like I could ask kinetic or potential energy. All right, what are some other words that we just...
Activation.
Yeah, that too could be on there. Precipitate's a good one because that's one that I really don't have a separate section classify as precipitate. No, but I have, so you might see words that, you may or may not see other places might be in that matching section as well. And words that we didn't cover a whole lot of. Like, remember entropy, that word? All right, and what are some other ones you might want to know? Well, just a whole classification of matter and all that stuff. All right, so there'll be a whole section in the middle. This, the third section, is going to be matching of terms. There's only about 8 of them, 7 or 8 of them. Then there's a section on, I just got the board a second ago, on observations, hypotheses, and experiments. I'm going to go over all these. Next section below that, potential versus kinetic energy, just like that, just different examples. Endo versus exothermic, just like that, different examples. And finally, some stuff on rates of reaction and classification of matter, okay? On the back side, here's where you're going to lose more points probably, all right? Let me read these kind of, short answer. Answer the following questions, all right, in as much detail as I gave you in class. These are not going to be memorization questions. These are going to be stuff where you're going to have to explain something on some major concept from the chapter. What's a major concept from this chapter we did? What did we just do the lab on yesterday? And we spent like days on it. What was it? Physical and chemical change. Absolutely. You're going to see stuff on physical versus chemical changes and maybe some of the stuff underneath that, where you have to explain, not just define. Physical change, no new substance is formed. A chemical change, new substance is formed. That's not enough. All right, if you look at your notes, you'll find that we spend a lot of time talking about physical versus chemical changes. If I ask you to explain something, it doesn't mean you give me examples of it. I hate when people do that. A physical change is like when you have something that just boils. And a chemical change is like when you have, no, I want my definition and I want it explained. Not just an example of a chemical change. Okay, I want an actual definition of the chemical change, explanation of a physical versus chemical change. All right, there's a lot of stuff on that. There's stuff on catalysts. There's stuff on the law of conservation. How many times did I talk about law of conservation of matter and energy, right? Expect to see it possibly in a short answer question. And, of course, there's a graph. All right, you saw, I just held this up a little while ago. There's one of the graphs. Graph that looks like, well, I'll do that at the end. The endo and exothermic graphs. Finally, there's a short answer question at the very bottom. Has to do with, again, mixtures, elements, compounds, and mixtures, and separating them. Kind of like I had at the bottom of this sheet, but I didn't put it on here for you to do again. Remember the one at the bottom of that sheet from last night? It had to do with separating salt and iron, right? Filings. Okay. All right. Let's go back and answer all these. And after we do all these, you should be set. Now, when I call on you, no one looks down. All right. It is a waste of time for me to call on you. And it always happens. We get down to the 5th or 6th one, and people aren't paying attention. I'll call on. And boiling water. Oh, okay. A. That doesn't. You didn't learn anything. I want you to think about whether each of these is a physical or chemical change. Then look down at your answer and see what you got. And let's do them out of order and call on people randomly so you can't look ahead. All right? So let's start with physical or chemical. Sydney, forming clouds.
Chemical.
So when clouds form, that's a chemical change. What's happening when a cloud forms? Condensation. What is condensation? Basically, it's a phase change. And what is a phase change? A physical change. This is a physical change. Everybody look down there. Did you put physical change for that? People. All right? And if you didn't, that's a mistake. And I told you I would do this, and you saw that in the homework on the board, too. By the way, I forgot to click on it at the end of the period. What time is this over?
11 after.
Oh, yeah, we have lots of time. All right. I told you I will do this. I'm not going to simply restate things as easily as you saw them. We know from your notes that any phase change is a physical change. Now, how can I say a phase change? Condensation on a glass, forming clouds, freezing ice. Those are the specific examples which you'll have to tell me is a physical change. All right, let's look at another one. How about Austin? What about melting ice? That is definitely physical change for the same reason. Phase change. See that? All right, let's go with Lexi. What about boiling water?
Chemical.
This is an amazing thing, Lexi. I want you to think about what I just spent the last 2 minutes explaining. What did I spend the last 2 minutes telling you were always physical changes? Think.
Wait, are always physical changes?
Yes. I just spent the last 2 minutes talking about clouds, condensation. He said melting ice. What are always physical changes?
Water. Well, confusion. Oh, phase change, sorry.
Yeah. And is boiling water a phase change?
Yeah.
This is what happens on review days. People kind of zone out. All right. It happens to be the least fun day of the chapter, but it also is the most important because I'm going to go over everything on a test. All right. I'm not talking for my health up here. All right. You need to be paying attention. So those three I purposely did first, so you can see all three of those are the same thing, just different ways of saying it. All right. Let's go with chopping wood. Maggie. A, physical. Still sticking with the physical here. That's physical also. If you look down as we do each of these, did you get it right? Okay. How about healing of a wound here by Alexis? Where'd you over there?
A, physical?
No. Anything that is biological, okay, is going to be a chemical change. I wrote that in your notes. Okay. If it's something your body does, if it's something a plant does, if it's something an animal does, healing a wound, smell, taste, digestion, anything like that. Respiration, fermentation, photosynthesis, chemical changes. Anything a living thing is going to do. Any biological. I wrote that down in notes, knowing that would be a mistake. Digesting food. What do you think about that one here, Jen?
Chemical.
Absolutely, because your body does it. So that's a chemical change. All right. Anything that's biological is going to be chemical. Okay. How about dissolving salt in water, Ethan?
Chemical.
No. What will make you say that's chemical? It looks like something new is formed. It looks like we lost our salt. It's gone. But is salt still there? And can we get it back? And why did we do that lab yesterday as part of physical versus chemical changes? Remember the lab yesterday? Okay. Notice how many wrong answers we're getting here. All right. That's a bad sign. All right. It's a bad, and it's also happening mainly because I'm not letting you look down. When you did these last night, I have a feeling that I'm not going to have anywhere near this many wrong answers from those sheets. Why? Probably did them together. Maybe some of you copied them off somebody who you know is smarter, and thought about them. Now, on the fly, hear me asking you questions, you're panicking, and you're not really thinking. You've seen salt dissolving in water in 2 different labs. We saw that. In the mixture lab, where we had the salt dissolved in water, to get it out, and we said that was a physical change. And yesterday, in the lab. That is a physical change. And burning paper, last one there, what do you think about that one, Josh? Chemical. All right, that's going to be B. All right, obviously burning paper is a combustion reaction. You know, you're not. And by the way, the way you can tell all of these things, let's go and talk about the distinction between physical versus chemical, having now done all these. In a physical change, I have no new substance formed. That's why all these phase changes. All those phase changes. I still have water. Water condensing, water boiling, water freezing. Still water. In a chemical change, you have a brand new substance, and here's the key. You can't reverse it. Can I reverse boiling and get the water back? Sure. Can I reverse melting ice and get ice back? Sure. I cannot reverse burning a piece of paper. It's burned, it's gone, it's not paper. Can't put it back together. Healing a wound, brand new stuff going on there. You can't get it back. All right, so chemical changes, they are irreversible. These guys are reversible. Chemical changes, you have a new substance formed. Here, no new substance formed. Chemical change, you have a new arrangement of atoms. Atoms are rearranged. I drew, you didn't have to copy them, but I drew multiple equations on the board over the course of the last couple of weeks. You know, I took HCl and added it to NaHCO3, and this is way off, by the way, as you can see. And when we rearranged those, it got salt and carbon dioxide and water. That was rearranging the atoms. That's not what's happening when you boil water. Okay? In phase changes and in physical changes, you don't have new atoms formed. Okay? All right. Let's go down to these. Hopefully that's good for physical versus chemical changes. Hopefully you won't make those same mistakes again. That's why you get that sheet. Okay? My problem with that sheet is I have a feeling going all these wrong answers. I mean, I'm not picking up, I don't know you guys from anybody. I'm picking up totally random, and we got about half of those wrong. All right? My guess is you didn't get half of them wrong on the sheet because you worked together on them, you used your notes, and you maybe copied off somebody who was smarter than you. But you can't do that on the test day. That's the problem. Now, let's go. It's been a long time since we talked about the scientific method. And I bet you there's going to be some mistakes in here. What is each of these classified as one of the steps of the scientific method? What do you think, Zach? Sun is bright. That's an observation. That's just a observation. Okay? Most people don't get that wrong. Dropping 2 objects from the same height, see if they fall at the same speed. What do you think of that one, Michael?
Experiment.
That's an experiment, right? You're testing something to see if they fall at the same speed. See. An unknown substance is shiny, so we believe it will conduct an electric current. Caleb. That's a hypothesis. I think this is going to happen, but I don't know. That's B. And it's based on an observation. That's why I think that. How about Kyle? Well, the next one. Unknown substance is flammable. Excellent. A. And I was like, both of you got it right, sounds like. Both Kyles. A. Observation. And that reason I said excellent for that one, because that's one that people often get wrong. They see the word flammable. They think, oh, that must be an experiment. All right? I didn't say that. I said I'm walking by something and I notice it's on fire. That wasn't an experiment. Here would be another way I could say that. I want to know if something's flammable, so I set it on fire. That's an experiment, right? Okay? But just saying something's flammable is just an observation, even though it happens to be a chemical change. All right, what about the last one? Based on numerous experiments, we think that all matter is made up of atoms. Liz? A theory. Because, you know, we're big, oh, letters D. Because, you know, we've done a whole bunch of experiments, and we still don't have a law. Remember, I told you about that. We don't really use the word law anymore, even though we do laws of physics, the law, Newton's laws. But in reality, we continue to test these things over and over and over again anyway. All right, we just have really good, you know, evidence for it. Can you ever prove a theory. Can you ever prove anything in science? The answer is no. And I know that sounds crazy because a lot of times people even use the words, well, that's a proven scientific fact. And that's just not true. There are no proven things in science. Everything in science is constantly re-challenged. I don't care if it's the law of motion in physics. They get challenged. All right? Every law of natural selection, all these things get challenged all the time. All right? Okay. So let's go to the next one. Endo versus exothermic. Now, you're going to know endo and exo. They're pretty easy to remember. The easy way to remember exo, exit, expel, what's happening in an exothermic reaction, you think here, Taylor. You need to pay attention, Taylor. I'm not asking you a question. I said, what's happening in an exothermic reaction? If you're listening, you heard me say exit, expel. What do you think? Energy is given off, right? It's being released. All right? And, of course, in endothermic, what's happening there? Obviously, it's being absorbed. All right, so let's apply that to burning charcoal. What do you think about burning charcoal, Gabby? Endo or exo? Don't look down. You think it takes more energy. It's absorbing energy. When I put my hands over that charcoal, you've all, I'm assuming, seen a charcoal fire. Whether it was on your grill or out in a campfire. Would you not agree that a fire, burning charcoal, is giving off more energy than it's absorbing? It's giving off energy. That's heat. This guy is going to be exothermic, B. All right, that's not a hard one. There are hard ones in here, and you should all have had B. If you look down, did you have B? Okay, exothermic. Melting ice, what has to happen for ice to melt? It has to absorb energy, correct? What would that make him? A, endothermic. Okay? All right. What about exploding firecracker here, Savannah? Exothermic, giving off energy. Fire. Think of things that are giving off energy. Exploding. That's going to be exothermic, or B. A chemical ice pack. If it feels cold, that's probably a hint that what's happening here. What do you think here, Gavin? A. Endothermic. It's absorbing energy from your hands. And finally, and this is the one that I'll bet you most of you got wrong. I want you to look down now. What do most of you have for this answer, Kyle? Most people have A for boiling water, or no? Most people have B. B. Most of you have B. But A is the right answer. Yeah. And here's why. Most of you have B, and I see a lot of people changing that answer right now. Most of you have B, exothermic, because boiling water is hot. And I told you that exothermic reactions like exploding a firecracker and burning charcoal are hot. They give off energy. There's a difference here. To make water boil, what do I have to do to it? I have to add energy to it constantly. Burning charcoal, exploding a firecracker, you just give them a little push and they give off a lot more energy than you gave into it, you put into it. That's why these are exo, but this guy's endo. And remember I told you the problem with, and there's the same question I got yesterday, the problem with this guy right here is that it happens at a temperature above your body temperature, so it's hot. I told you that. That's why I had usually feels hot or usually feels cold. It's not always. All right, let's get down to the next one. 19. Stored. These are potential versus kinetic energy. Okay. Potential energy is stored energy. Kinetic energy, energy of motion or transferring heat. Right. So obviously 19. You're not going to get that wrong. What do you think about 19 here, Jacob? Potential. Potential. It says the word stored right there in it. Can't get that wrong. Gabriel, what about a mill wheel being turned by a stream? Kinetic. Okay. Simple enough. An exploding firecracker. Now, it's not necessarily about the motion, but maybe about the heat. What do you think about that one, Margaret? Kinetic, B. And a ball at the top of a hill. What about that one, Eric? A, which is? Potential. All right, because it has energy at the top of the hill. All right. As it rolls down, it would be kinetic energy. All right. Element, compound, or mixture. Everybody should have gotten, I would think, this one right. Copper's right there on the periodic table. He is an element. Chocolate chip cookie, surprisingly, people will put down as element. Where you are not Cookie Monster. He has his own periodic table of cookies. Chocolate chip cookie must be a mixture. C. I would hope you all know that. Water, what's water? One of the 4 compounds. And sugar, one of the other 4 compounds you have to know. I don't expect you to know a lot of compounds yet. You're going to learn about how to write the formulas for and know how to do these compounds in the future. Right now, water, sugar, salt, carbon dioxide, those are it. All right, they'll be the compounds I'll ask you. What's the difference between elements, compounds, and mixtures? Well, elements, they're right there on the periodic table. Compounds, chemical combination of those guys. Mixtures, physical combination of these guys. Okay, that's the big difference. Compounds are chemically combined where you can't separate them, and they lose their properties. Water is a classic example. Hydrogen's a gas. Oxygen's a gas. Put them together, you get water, neither of which are gases. Can't breathe water, I can breathe oxygen. Can't burn water, I can burn hydrogen. Put them together, that's why it's totally different, loses its properties. Finally, homogeneous or heterogeneous. People get this one wrong too. People get it wrong. Salt water, I hope you realize salt water is going to be homogeneous. It's going to be basically the same throughout. But people are not. That's heterogeneous. And a rock, many people put down homogeneous. It is not. It is going to be heterogeneous. Rocks are not going to be exactly the same throughout. If I break a rock, some parts have more sand and more granite and more or whatever in it. Other parts have less. Some are darker colored, some are lighter colored. A rock is a rock. It's got a lot of other junk in there. And any living thing is going to be heterogeneous, by the way. Not that a rock is a living thing, but I'm just saying. Any living thing would also be heterogeneous. All right? Okay. Now, the last question I had on that worksheet was about separating things. And I won't have a chance to just pass it in today to pass it back to you. I will say this. I want to know what property you're using as well. What property? So, for example, in that worksheet I just gave you, it said, describe 2 ways you could use physical properties to separate a mixture of salt and iron filings. I would expect you would tell me, well, the 2 ways you picked were good ones. Could have picked them out with a magnet, right? Magnet could have done it. Or you could have dissolved in water, and the iron filings would have not dissolved, and salt would have. But what are the properties for those 2? Well, you should have said magnetism is the property for the one. And what's the property for the other one where you're adding water? Solubility is the other property. Okay, so those are the properties you're using. I will ask, guaranteed to ask a question similar to that test. Think back to the lab we did. All right, the lab we did where we had the marbles and all that other stuff. How did we separate those? We don't do labs for no reason. This chapter had more labs that weren't related to the class because of the safety stuff we had to do first. But most labs have some relationship to, which, by the way, let's go back to that previous one. You know, when I had people getting a lot of these early ones wrong under physical versus chemical change. Remember, about half of those were wrong. We did some of those right in the lab. Boiling water, dissolving salt in water, right? We did those right in the lab. Yet people still got those wrong. That's the whole point of doing a lab, so you don't get those wrong. All right. On the test, last thing I wanted to tell you was, well, you know, I'm going to go back one more. Here. Last thing I want to tell you was you're going to get a graph on the test. You saw it a minute ago when I held this up. It'll be either this one or it'll be this one. And you can memorize your way through this, but there's really no reason to. This is energy versus time. Energy versus time. Right? And if I have a guy like this, I could just tell by looking at him all the questions I could possibly ask you about him. What are the questions I could ask you about these guys? Number one, is energy absorbed or released? That you can tell by looking at where he starts and where he finishes. Where he starts and where he finishes. If he started here and he ended up there, what must he have been doing the whole time? Absorbing energy. He got more energy. If he started here and ended up down there, he must have given off energy. Got it? All right. If we know he's releasing and he's absorbing, I think of the word. Endo or exo. Exo, expel, excrete, exit. This guy is probably the exo one, and this guy is the endo one. Notice what I'm doing. I am not memorizing. I'm not, oh yeah, I remember this in my notes. It's up here in the right-hand corner. I'm thinking about it. I'm looking at the shape of the graph. If I ask you which one's more likely to be spontaneous, which one would you more likely see a ball rolling from top to bottom? Obviously this guy is more likely spontaneous, right, versus that guy, right? How about if I ask you which one's going to feel more likely to feel hot, giving off energy, therefore. Wouldn't you say this guy right here, right? More likely to feel hot? That guy more. Again, these are not written in stone because it depends on where they happen. And what else could I ask you about this stuff? I could ask you about what that little thing is up there. And in this case, it's this much. What do we call that? Somebody said it before. Activation energy. And where does that come into play for something else we talked about where I can lower that activation energy? Catalyst. Okay? So you should know how a catalyst works, and all my notes on a catalyst. I might ask you a question on that as well. I just went over the entire test. There's nothing, pretty much nothing, that you're going to see tomorrow that will surprise you. That's the entire test. All right? If you study tonight, and obviously you need some studying tonight, because those worksheets, I just went over, there were a lot of mistakes early on. Okay? I would recommend studying that tonight. Now, I need to have